So this is going to be a companion of 10-1 graphing absolute value functions. And so I'm going to graph a couple of things and I'm going to talk about the predictions. So I do y equals x. I know that that's the linear parent function. If I add, I'm just going to keep graphing and I'll delete some of the graphs as I go along. So if I do y equals the absolute value of x, it becomes a function that has a vertex, a line of symmetry, and all in the positive y values. And then if I do y equals, and I do the negative absolute value of x, it basically reflects across the x-axis. And it has a maximum instead of a minimum. So this one has a minimum, and this y equals negative absolute value of x has a maximum. This is going to follow a lot more functions that we introduce along the way, and that always happens. So we're going to go into quadratics later, and everything you learn about absolute value can be applied to quadratics, and it can be applied to circles and other functions. Okay, now I'm going to do y equals the absolute value of x plus 2. Okay, and I'm going to take out these graphs. So, and I'm going to take out that one, and then I'm going to do the y equals the absolute value of x. And I'm going to move them back around. Okay, so if I graph the y equals, I'm going to turn that one off. If I do the parent function y equals absolute value of x, and then I do the y equals absolute value of x plus 2, where 2 is on the outside of the absolute value, what that does is it shifts the function 2 units up. So then I would say, how are you going to shift it 2 units down? And so I would say, let's try y equals absolute value of x, and then outside the absolute value and do minus 2. And so I shifted it down. So anytime that you add a value or subtract a value outside the absolute value, that is shifting it up and down. So I changed it to 3, and it took the parent function of the absolute value and shifted it 3 units down. If I change this to a 4, it changes the vertex to 4, and it's the parent function moved 4 units up. So not all absolute value functions stay along the y-axis. So now we have to learn how to move it left and right. And x kind of follows a great rule, but it's not an obvious rule, so pay attention when we do this. So y equals the absolute value of x minus 3 in the absolute value, takes it and moves it to the right 3. Now, this is where x doesn't really pay attention to the rules, because when it says minus 3, most people think, oh, we're going to move left 3. X doesn't ever do that, and it doesn't do that in all the functions that from now on. Okay? And if so, I just moved it to the right. So if I wanted to move it to the left, I would do the absolute value of x plus 4, moves it to the left. So adding to the absolute value moves it to the left. Subtracting from an absolute inside the absolute value moves it to the right. And so we can do combinations now. So I would say move something up 4, right 3. Okay, so if I did, and I'm going to start with y equals the absolute value of x, and that's the parent function. If I want to go up 4, I'm going to add 4 outside of the absolute value. If I want to go right 3, I have to go back in the absolute value and do minus 3 for right. So if you notice that this parent function moved up 4, right 3, that's how you do it. Okay, so now say I want to go down 2 and right 6. Okay, so I start with the absolute value. And I always start with the absolute value. Oh, let me take him out so he doesn't confuse us. And I'm going to go down 2. So outside the absolute value, I get him down 2. And now I want to go right 6. Right usually is positive because positive's over here, but x is strange, so I do minus 6. And that is, ooh, no, yes. And that, let me erase this. So this was right 6 down 2. That is right 6 down 2. And that is going to follow circles. It's going to follow quadratics. That's how you move functions. So let's do one more. Let's go up 4, left 3. So I always start with the absolute value function. And I'm going to take this one out so we don't have any there. So I'm going to do up 4. Up 4 means outside the absolute value. And left 3 means in the negatives, but x doesn't really do that. So we're going to add 3, and that is up 4, left 3. So in this unit, you're going to be given a graph, and you're going to have to come up with the rule, or given the rule, and you're going to have to come up with the graph. You're going to have to be able to realize the movements and be able to graph them and tell whether it has a max or a min. Okay, so then you'll have one more example before I end this lesson. Y equals negative absolute value of x plus, well, plus 3 is going to move up. And if I want to move it to the left, I'm going to do a plus 2, and it moved it to the left. So I can reflect it over the x-axis. So you're going to have to be able to do movements and figure out which, what the graph is going to look like by equation. And you're going to have a graph and be able to come up with the equation, or an equation and come up with the graph. You're also going to have to come up with the table. I will then now go over the notes, and you'll see that the notes are going to mimic what I just said.